All right, taking a look here, 4.8, example 1, all they're wanting us to do here is to graph the function. Okay, so the function that I have that they give me is f of x equals 1/4 x minus 2 x plus 3 squared. It's been a little while since we've done something like this. The nice part about if they already have it factored some of the way is that I already know some of the zeros. What are some of the zeros for this function? 2 and negative 3. When I say zeros, I mean what? Crossing what? That's crossing points for the x-axis. That's where those points are where it crosses the x-axis. Okay? So I'm going to go ahead and graph these because I know my function is going to cross there. Okay? So one's at positive 2 and the other one's at negative 3. Now, with just those 2 points graphed, if I gave you no other information, you're either going to think it's a line or a parabola, right? Okay, if I gave you no other information. So you still have to do other things. Now, looking at this graph, see if anybody remembers this. What does it mean when my binomial is squared? What does that tell us about this graph? True, close. Something special happens at this point that's different than this point.
If one goes up, one goes down.
It doesn't actually cross. It touches and goes back the other direction. So, anytime you see something squared, that means instead of crossing, like it's going to over here, it's going to just touch and go back. Now, we don't know which direction. It could be like this. Okay, but I know that it's not actually going to cross the x-axis there. It's going to touch it and then go back in the opposite direction. So just keep that in mind. Okay, what degree is this polynomial? This is tricky. It's not a second degree. It's a third degree. There is one x in here, x to the first, and because this is squared, there's an x squared in here. So there's an x squared and an x to the first, and you're multiplying them together, so you add your exponents for 3. Okay, so just be careful of that. Understand what you're looking at there for exponents. So this is a third degree, so at most, I could have how many turning points? 2. Max of 2. Now that doesn't mean there's going to be 2. It means there's a max of 2. Okay? So for my other points, I'm still just going to make my XY chart. Now the nice thing about what you have going on, you probably aren't going to have to make the whole XY chart because there's going to be multiple choice, right? Something similar as to what you'd see on an ACT. There's going to be multiple choice. Okay? So I'm still going to pick negative 2, negative 1, 0, 1. I'm not going to put 2 on there because I already know what 2 is. Okay, so I don't need to mess with that. So I'm just going to get these other 4 points here for me. And to find the y value, you just got to plug in, right? Okay, so that's probably the most work that these problems are. So negative 2, let's just do this. Negative 2 minus 2, negative 4, negative 2 plus 3, 1. 1/4 times negative 4, negative 1. 1 squared is negative 1 times 1, negative 1. Then you got to start over. Negative 1 minus 2, negative 3. Negative 1 plus 3, 2. 1/4 times negative 3. I'm going to leave it as a fraction. 2 squared is 4. What happens here? Those can cross, right? So negative 3 over 1 is just negative 3. 0 minus 2, negative 2, 0 plus 3, 1/4 times negative 2. Very close. Negative 1/2 times 9, which is negative 9/2, which is 4.5. Okay. And last one, 1 minus 2, negative 1, 1 plus 3, 1/4 times negative 1, negative 1/4 times 16. Negative 4. Okay. Again, you're probably not going to have to do all those points on yours. You're just going to have to find a few that work and the other graphs it won't work in. Good, Peyton? Okay, so go ahead and graph these. Negative 2, negative 1. Negative 1, negative 3. 0, negative 4.5. 1, negative 4. Okay. Now you also have to understand what a cubic looks like. Okay. If it has any turning points at all, it's got to have 2. It can't have 1. Okay. Remember when we were graphing our functions, a cubic has to go up on one side and down on the other. Right? Okay. So I know that it turns here but never crosses. So I know on this side this is happening, right? Yeah. And I know over here, then, it must be continuing up this way. Again, you don't actually have to draw those graphs. You have to select the correct graph.
How do you know which side it only touches and not
The square.
Okay.
Yep. Because the x plus 3 has the squared on it. Which if there's ever a squared on it, that means it's touching it but not actually crossing it. Okay. Let's see here. Oh, some confusion that we had the other day when we were talking about turning points. Your turning points are actually points. Okay. I had people saying, well, there's 1, 2, 3 turning points. Those aren't turning points. Those are just places where the graph is going different directions. The turning point is where it changes direction. This is a turning point. It changed direction right there. This is your other turning point. It changed direction right there. Okay, so just be aware of that. Other than that, it's just graphing for that example. Okay, now moving on to page 213, they're talking about the location principle here, and I think how they word it is confusing to most people. If it's not, then that's great, but it has been in the past. What they tell me is that if f is a polynomial function and a and b are two real numbers such that f of a is less than 0 and f of b is greater than 0, then f has at least one real 0 between a and b. Okay? For most people, that's a whole lot of stuff going on there. Okay, all they're telling you is that if I have this graph and there's a 0 here, or excuse me, there's a point here. It's not a 0. There's a point here and there's a point here. One's below the x-axis, one's above the x-axis. The location principle says there has to be a 0 in between. Well, obviously, because if one is below the x-axis and one is above the x-axis, somewhere in between it's got to cross the x-axis, right? Okay, so that's all your location principle is telling you. So what they're saying is if you have these points here, there has to be a 0 in there somewhere in between them. Okay, so if you have a point at positive 4 and a point at 6, somewhere in between 4 and 6 is a 0. Okay, that's all they're saying. Does that make sense? Okay, that's all the location principle is, so don't let them confuse you with that. Okay, now, example 2. And this is reaching back to 4.5. which I asked you to make sure you went over, and I will check those here after we're done. Okay. We are finding zeros of this polynomial function. So they give me the function f of x equals 4x cubed plus 28x squared plus 21x minus 18. Since there are 4 things there, what is the way you should attempt to factor this by? Grouping. Okay, you should attempt it. And I will tell you on your assignment, there is for sure one that I saw that you can factor by grouping. Okay, so don't just skip to the hard stuff. Try to factor it. Okay, now I'm going to go ahead and tell you this one is not factorable. So we're not going to spend the time checking it, but it does not factor out. So then we have to go back and we have to use our rational roots theorem. Okay, and that's been a while. Our rational roots theorem was when we take the factors of this divided by the factors of this and list all our possible factors out. Okay, so I'm going to just start with 1 there. 1 over 1 plus or minus 1 over 2 plus or minus 1 over 4. Okay. And then I have plus or minus, what's the next one here? Actually, let's do this a little bit differently. Let's do it. Let's go like this. Let's do all our whole numbers first. 1 over 1 plus or minus 2 over 1 plus or minus 3 over 1. I'm getting the top numbers from the factors here. So plus or minus, what's the next one? 6 over 1 plus or minus 9 over 1 plus or minus 18 over 1. Okay, that's our rational roots theorem. And the next one then, let's go ahead and go put the bottom numbers to 2. So I have plus or minus 1 over 2, plus or minus 2 over 2, which is actually just 1, which I already have up here. So I don't need that. Plus or minus 3 over 2, plus or minus 6 over 2, which actually is 3, which I already have, plus or minus 9 over 2, and then plus or minus 18 over 2, which is just 9. Okay, and I could keep going if I needed to, but after getting that many listed out, I would hope that I've found at least one, right? So what I would do next was what? What did we do after this to make it a little bit easier on us? Okay, we are going to use synthetic, but instead of guessing and checking all these, how do we figure out which ones to guess and check?
Oh, we can graph.
Yeah, go ahead and graph it. Okay, so we're going to go ahead and put this on GeoGebra quick. Okay, so I already have GeoGebra pulled up. Okay, and I'm just going to type in my function. What was it? 4x to the third plus 28x to the second plus 21x minus 18. Okay, so here's my graph. Don't need this anymore. Is everybody with me? Okay, so here's what my graph looks like. I could zoom clear out, it's pretty steep. Okay, but what really matters is my intercepts, right? Okay, now I see I have negative 6 here, which is one of my options, correct? Okay, I'm not going to mess with that negative 6 because of the fact that it's a whole number. Okay, I'm going to try to get rid of my fractions because that whole number is going to work its way out in the end. Does that make sense? Yes, no, maybe? Okay, if I get something in the end and I'm able to factor it, I'm going to factor it into whole numbers. But if I use that whole number first, the very last thing I'm going to come up with is going to be a fraction, which isn't going to be very fun. Okay, so I'm going to try to eliminate these fractions first. The first fraction that catches my eye that should be fairly easy is 1/2. Okay, was that an option? Yes. Okay, so I have 1/2, and like Peyton said, we are going to use synthetic division now. So I'm going to list out all these. So I have 4, 28, 21, and -18. And I'm going to synthetically divide that with positive 1/2. Okay, we remember how to do synthetic division? Okay, so drop your 4. 1/2 times 4 is 2. 28 and 2 is 30. 1/2 and 30 is 21 and 15 is 1/2 and 36 is 18, and that's 0, which it should be if it's a 0, right? Okay. So that means one of my factors is x plus 1/2, correct? You're right. Thank you. Minus 1/2, because this is positive. What does this give me? A new polynomial, which is? Keep going. Good. Okay. And then we're going to go back and we're going to synthetically divide our other fraction. I wouldn't. Okay, what I would do is I would take a 2 out of all this to make my numbers a little bit smaller. So I have 2x minus 1/2, 2x squared plus 15x plus 18. I just factored a 2 out of all of that. Go ahead.
Why is it not like x minus 2?
Why is it not x minus 2?
Because it's not a 0.
Yeah, all I'm doing is dividing it out. If I multiplied it back in, it'd be the same thing as what was up here. If I did x minus 2, then I'd have to FOIL it out. I'd end up with an x cubed in there.
Okay.
I'm just dividing everything by 2, essentially.
I have a question.
Go ahead.
So you know how you put it out in front? Wouldn't you distribute that into the first space? You know what I'm saying?
I mean, you could, but we don't want to because then you could factor it back out. We're going to leave this in simplest form. So if I can break it apart, I'm going to break it apart. Okay. What was our other intercept over here? Negative 1.5. Is that one, or was that one of our options? Right there, right? Negative 3/2. Okay, so now I'm going to take this, and I'm going to do synthetic division again. So I have 2, 15, 18. But this time, I'm going to do it with negative 3/2. What is negative 3/2 times 2? Negative 6/2, which is negative 3. 15 plus a negative 3 is 12. Negative 3/2 times 12, negative 36/2, or negative 18, which is 0, which it should be because this is a 0. Okay. So stealing all this information from up above, I have a 2. I have an x minus 1/2. I have an x plus 3/2. Fractions, please. Your assignments will be in fractions. And then this gives me 2x plus 12, correct? Is there anything you can do with that? Take another 2 out. Now, this is what confuses people sometimes. When you take that 2 out, it's like multiplying by 2 out here. So it's 2 times 2 is 4. x minus 1/2, x plus 3/2, x plus 6. See how that came out with a nice number there? If you would have started with your 6, you'd have been messing with fractions at the end. Okay, and I'm going to try to avoid that. Okay, you could have started with 6 if you really wanted to. I just like my last one to come out as a whole number. Okay, but if you want to start with that number, that's just fine. You should get the same answer. Okay, so my zeros are 1/2, -3/2, and -6. What was I going to ask? Oh, does that make sense that there are 3 zeros when I started as a cubic function? Yes. Does that mean that there has to be 2 turning points? No, it means there could be at most 2 turning points. Okay, Peyton, what's up? Yes, I can.
So, you don't do anything with the 4, right?
Right, because if I set 4 equal to 0, it doesn't give me an x value.
Okay.
You just get nothing.
Yeah, 0.
Okay. So, real quick, if you would, on page 214, I just want to talk about this last thing quickly. We are now talking about local maximums and local minimums. Okay, when we were doing parabolas, remember the y value of the vertex was your maximum or minimum depending on how your parabola was drawn on the graph. You guys remember that? If my graph looked like this, whoops. If my graph looked like this, it was a minimum. If my graph looked like this, it was a maximum. Okay, it told me my lowest height or my highest height. Okay, with these polynomials, since they could keep going, okay, this is not your maximum because obviously my function is higher over here, right? Okay, but it is the maximum here. Agreed? So we would call this a local maximum. It's a maximum of what's around it. And in this case would be 0 is my local maximum. This is the lowest point around it here. Okay, so -4.5 would be my local minimum. It's not the lowest point on the graph. It's just the lowest point right there. Does that make sense?
Is there only going to be one of each?
No, there could, depending on the degree. Okay, it's always going to be at a turning point. Your local and max and min will always be at a turning point. Okay, just understand there are higher and lower points from there. That's just the max and minimum right around it. Make sense? Okay. Every time there's a turning point, it's either going to form a local maximum or a local minimum.
So there could be like.
Yeah, there could be 20 of them on there. If there is a
like
21st.
0 and 2 or whatever.
Yep. Okay. The last thing there that I want to talk about today, your core concept, it's talking about the number of turning points. Okay, we've already said that's the degree minus 1 is the maximum number of turning points, right? Okay. So go ahead and work on that assignment. Most people have been able to finish that in class. I need you to get through 21. Through 21, please.